So yesterday we came up with the circle equation, so let's write that down again. X minus h squared plus y minus k squared equals r squared. That way it's on the top of our paper up there so we can look at it, all right? Now, they could ask a lot of different kinds of things about circles. So you could be asked to write an equation like you had. Maybe they give you an equation and for some reason you need to find the center and the radius. Hopefully you have some idea of this, but if you don't have some idea of what this actually is, then you're not sure what to do with these signs. So don't forget it's minus minus in here and that is r squared, which means that the radius is actually the square root of 4, right? So we know that the radius is 2. You're not just going to take whatever that number is. And then to find the center, what would be the h value that I get out of here? -3. Very good. And this one would be 5. So super simple question, right? If you have some concept of the circle equation, okay? And it very well could be that easy of a question, because if you'd never seen that or hadn't seen it since geometry and you don't remember it, chances are pretty good you wouldn't be able to pull out the numbers correctly, right? Or some of y'all would start doing weird things like trying to square everything and solve it somehow, and I don't know. But you always try and make things as hard as possible. We don't want to do that. All right, so let's look at this one. For our center, what would be the h value? -7, good. And the k value? 0. Very good. Okay, because that's like y minus 0. Now here, when I take the square root of 48, that's not a perfect square. Now, all the ones that I gave you on Delta Math should be perfect squares. If they're not, then they're the ones that you're going to substitute back in and square it, so it doesn't matter. If you get something that's not a perfect square, and on the SAT, you have access to the calculator, so you could type in the numbers and match decimals. I think y'all know how to manipulate that. But just for the sake of this, we're going to go ahead and simplify this because this is also a skill that we need, that you've all been taught, most likely taught the first time in geometry, then should have done it again in algebra 2, probably algebra 3, I don't know. But there's different ways to teach this. Some teachers teach you to find the largest perfect square that divides into 48 or whatever the number is. I don't think that's the best way to do it, because some of y'all would be sitting there guessing and checking forever to figure out what the biggest perfect square is. Some of you could probably look at the number and just know, that's fine. But instead of trying to overthink anything, just start making a tree. We're going to do prime factorization like you did in elementary school. So just give me 2 numbers that multiply to give me 48. Okay, I heard 12 and 4 first. I also heard 6 and 8. We could also do 2 and 24. All right, so I just went with whatever I heard first because it doesn't matter. All right, so then this 4 can become 2 and 2. Now, once you get to prime numbers, circle them. Okay, that 12 can become 4 and 3 or 2 and 6. It doesn't matter. 3 is a prime number, so I'm going to circle it. And then 4 is 2 and 2. Now, are there other shortcuts you could do to this? Absolutely, but I'm just showing you what to do that works every time, and you probably don't do it that often. Might be the best way for you to handle it. So then we start looking for pairs, and they don't have to be next to each other, but it's all my circled numbers, so I knew where my branches stopped. These 2 2s come out of the square root as a regular 2. This 3 doesn't have a pair, so let's take care of these 2 2s, also come out as a 2. And that 3 stays inside. So my answer in the end is 4 square roots of 3. Again, on the SAT, because you have access to Desmos the whole time, if you needed to take the square root of 48 and you had different answer choices with square roots, you could type each of the answers into the calculator, type that one in, and make sure that they match. They'd probably be whole numbers in this situation. I just left this one on here because it was what it was and something we can at least look at. Okay, we good so far? All right, so another thing that, I mean, you're not going to be asked to physically graph them on the test, but you might have to take an equation and match it to a graph. In Delta Math, you're going to have to graph them, but the little circle will already be there. You just have to move the center and change the radius. So it's going to be a lot easier than what we're going to do here and look better. But in order to graph it, I need to know the center and the radius. So looking at this first one, what's my center? 0, 0. Good. And the radius? 5. Okay. Everybody understand how we get that from the equation? All right. So I'm going to plot my center. It's right here. And then from the center, I'm going to go to the right 5 And then from the center, I go up 5, back to the center left, back to the center down. And then the only 2 circles you may ever have to draw on your own for the rest of your life without some sort of tool might be right now. Okay, we're just going to do the best we can. For me personally, because it's not going to look that good, it's easier to kind of dash it than to try to actually draw it. So if you just do your best to make it not look like a square, it might kind of look like an egg or a football, but that's actually pretty darn good if I had to say so myself. But yeah, mine never look that good. They always look all wonky. So just do your best. Just get the idea. That's all I wanted you to have the idea of it. Everybody good? All right. What is the center of the second one? -1, 2. Very good. And the radius? 3. Good. So my center's not at the origin. I'm going to go to -1, 2, plot my point. Then always make sure you go from the center. From the center, I'm going to go to the right 3. Oops. Try to change that one. To the right 3, back to the center, up 3, back to the center, left 3, so forth, and then just do your best to sketch that circle. Yeah, that one's not nearly as good, but it's fine. So they could have a circle and 4 equations, or they could have an equation and 4 circles. Either way, for you to be able to match up what's what. Okay. Any questions at all? All right, good deal. So yesterday, we wrote some equations given the center and a point on the circle. This one gives me the endpoints of the diameter, okay? So the radius goes from the center to any point on the circle. That's why we're able to use those things. But the diameter goes across the circle, but it has to go through the center. So like here would be an example of one place I could draw the diameter on this one, right? In order for me to be able to write an equation, I need the center and I need the radius. So for me to find the center, how is the center related to the 2 endpoints of the diameter? It's in the middle of it, right? So I can find the center from these 2 points very easily. And that uses the midpoint formula. I'm going to write the midpoint formula out. We're not really going to necessarily, I mean, we're technically going to use it, but you don't have to overthink it that way. But this is a formula you should have seen before. Your midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. Does that look familiar? That's a geometry thing. But if what you're trying to find is the middle, always think about taking a piece of string. I'm going to take a piece of string, I'm going to bring the ends together, fold it in half, that'll get me the middle. Because I'm dealing with 2 ordered pairs, we never mix x and y. So I'm going to average the x's and I'm averaging the y's. That's all that's really happening here. So my center, I'll take my 2x values, -3 plus -7. I add them together, divide by 2. Then 8 plus a -6 over 2. Notice we're not subtracting like we did in the circle formula. We're adding and then dividing by 2. That's how you find the middle of something. X's together, Y's together. So then -3 plus -7 is -10 over 2 is -5. 8 plus a -6 is 2 over 2 is 1. There's my center. So now we're at the point where we were yesterday when we had a center and a point on the circle. But I actually have 2 points on the circle. It does not matter which one you use. If you use one and your neighbor uses the other, your work will look different, but in the end, you'll have the same answer. My suggestion is to always pick the one that makes your life the easiest. If there's one with no negatives, that's what I'd go with. But I do have one that at least just has 1 negative. So I'm going to use this point in my center. So I'm going to mark that ordered pair out so I don't accidentally use those numbers. Y'all know that happens when you just look back up and you pick the wrong number off. So just like we did yesterday, this is my HK, this is my XY, and I've got to find R. So I do X, which is -3, minus H, which is a -5 squared, plus Y, which is 8, minus K, 1 squared. That's equal to R squared. Everybody with me? Because now it's just like I said, like what we did yesterday. So -3 minus a -5. I can always make that plus a positive. So that gives me 2 squared plus 7 squared equals r squared. So that's going to give me 4 plus what's 7 squared? 49 equals r squared. So r squared equals 53. R equals the square root of 53. And even if I could reduce this, like let's say I got 48 here, I don't care. There's no need to simplify the square root because I know I'm about to substitute it right back in and square it. So now I have my center point and I have my radius, and I'm going to mark out that ordered pair because I'm done with it and I don't want to accidentally use that number. So now with those two things, write the equation of the circle. You can check yourself with me. Any questions at all? Circle stuff not so bad? It's not so bad if you can understand the equation at least a little bit. All righty. Last little way to use this stuff. We could be given an equation and just be asked, are these points on the circle? We don't need to try and graph this circle or do anything like that. If the ordered pair 2, 8 is on the circle, then when I substitute it in here, I should get a true statement. So we're going to use this as xy, and we're going to substitute it in and do 2 minus 4 squared plus 8 minus 6 squared, and then I'm going to put equals with a question mark. Does it equal 8? Because that's what I'm trying to figure out. 2 minus 4 is -2 squared plus 2 squared, and does that equal 8? Negative times a negative is always positive, so this is 4 plus 4. That does equal 8, so this is a yes. Okay. That makes sense? Just plug it in, see if what comes out is logical. Any questions? All right, then if that makes sense, you do B. And if you get to a part where it's obvious the answer is no, it's okay if you don't even complete it, because I know that -7 squared is 49, and then I'm going to add something else to it that's going to be positive, so that's already way over 8, right? And so the answer is just no. If you did finish it out, this would be 49 plus 1, and that definitely does not equal 8. So, okay. Any questions at all? All right, so your assignment today is also in Delta Math. I assumed, well, I thought you'd have more time to work. I wasn't thinking about the quiz taking as long as it did, and that's okay. So you got about 5 minutes. You could get started on it. Wouldn't kill you, because some of this is going to go very quickly.